Is 10 success?
Yeah.
Okay.
Yeah.
Okay.
First view.
Failure, so point, numbers in my second.
Alright guys, let's start to take a look here. Here's the numbers I got for the table up here. So I got 15.8. But now how did I know to make this? Because you teach. Yeah, but the formula tells me I need to add up these, so I got to make a bunch of these before I can add them up. And then the variance formula says I need a bunch of these, and I have to add them up, so I have to make a bunch of these, so then I can add them up. It's crazy. All right, now real quick, before, I just want to get that done while you guys are talking. How do I verify that it's valid? Well, all the probabilities have to add to 1. So you can either say that in English, or you can say it in Mathish there. And also, all the probabilities have to be between 0 and 1. So, I will sometimes make the probabilities add to be like 0.9998. That's not 1, right? But is it invalid? No, it's close enough. But don't just say sums up to 1, because then I'm like, you didn't actually look at the damn thing. Come on. So just, I might make them add 1.0001 or something. Actually add them up. So the mean, I already have the mean staring me in the face. What's the mean? Oh, sorry. Yeah, here it is. 15.85. That's the sum of these. And then the variance is going to be this guy. That's the sum of x squared p of x. So that goes right there. What was it? 2.9. Minus the mean squared, 15.85 squared, Jeff, whatever accent that is. So if you do that, let's see what you get. 294.29.
43.0675.
Thank you, sir. So that's the what? Variance. And then to find the standard deviation, you just take the square root of that. So I get 6.563.
No. Yeah.
Alright, how you guys doing?
Good.
Okay. I know 2 of you doing alright. So that's that kind of problem right there. And please, dear God, let it be really simple to tell which formulas to use. It's got x and p of x. You should probably use the formula's got x and p of x. And then this situation, what's 89 going to be?
No.
N. What's 0.12 going to be? Yeah, because it's a success. That's what I'm going to be looking for. Q is 0.88. And exactly 10, so the probability that x is 10 So it'll be 89 courses, choose 10 of them. I love this formula because it's very repetitive. So how many successes do you want? Freaking 10 of them. So how many failures do you want? The rest of them. And then it's just a question of, do you remember how to put that in a coupler? 89, math, probability, choose. Where did it go? 10, right? Times 0.12 to the 10th times 0.88 to the 79th. 1295? 95?
Yep.
Alright, cool. And then this is the best mean and standard deviation formula yet. And it only makes sense. If 12% are distance ed and we randomly pick 89, how many would we expect, or otherwise known as the average, would be 12% of 89? N times P. So the mean is NP is 89 times 0.12, which is what? 10.68. So we expect about almost 11. If we pick 89, we expect almost 11 of them to be distance ed. And the standard deviation would be square root of NPQ, square root of all that business. What do you guys get? You should get, yeah, 3.066. I like it. So one of the most immediate things you could do with that information is to see what would be unusual or not. So where does unusual start? How far away you have to go? Yeah. Sorry. It depends on what night it is. Yeah, that's true. So 2 standard deviations up, so I just take 10.68 and I add 2 of these. You guys with me? And I take 10.68 and I subtract 2 of these. So what do you get? Let's see. What do you guys get for the minimum? 4.548. I like it. And then for the other side, I like it. So that's what I expect. If I pick 89 college courses, community college courses in California, I would expect between about 5 and 16 to be distance ed. So would it be unusual to find 6 courses out of 89? Nope. Inside usual range. Or however you want to say that. You can just go, nope, 6 is in there. Because that's usual, and this is usual. It's close to the mean. You expect to get close to the expected value. That's why we call it expected value. It's crazy. You don't expect to get out there. All right, how are we doing there? Is that decent? Yes, no? This is, now just to make sure you guys understand, this last problem will not be on the quiz. That's the new stuff. The quiz is going to go from here to there. Whee! That's it. I can make more. You sound disappointed. Don't challenge me that way. So here's the last one. I like giving people a chance to do the homework. So now this guy, I told you it was normal, because if I didn't tell you it was normal, SAT scores are known to be normal. If I didn't tell you it's normal, you could not use this. You can make z-scores, but you could not use this. This only works for normal distributions.
On the homework, is it obvious that it's not normal, or?
They are not going to give you a problem that you can't do.
Do it, okay.
So just always assume you can. If you can't see it, you can put, I don't see where they say it's normal, Jeff, or something. They're really kind of loose about that sometimes, and that's actually a big point. So that's one little thing I don't like about it, but I'll say that. So here, if you're smart, you'll draw the picture. Otherwise, you won't. So we'll see which one you are. I want greater than 939 SAT score. So, of course, what's the very first thing I need to do? Good. Get the z-score for 939. I want to see how far away from the mean it is relatively. And what do you guys get for that z-score? Negative 1.11. That sounds familiar. So if you look up negative 111, will you be done? Shit? No. Negative 111. 1335. And of course, you immediately, the minute you look that up, don't even think about the question. The chart can only tell you below what you just looked up. But the question wants above. So you just do 1 minus that. You get 0.8665. Okay. This one, do a little picture. 1083, 1300, and 1400 are going to be way up there somewhere. Yeah, little overachievers. So you got to make a z-score for both, right? So you got to make a z-score for 1300, and a z-score for 1400. So what do you guys get for a 1300 z-score? 1.68. What do you get for 1400? 2.45. Okay. Crowdsourcing, I like it. So if you look up 2.45, that goes way too far. So I got to look up 1.68 and subtract that. So it just limits it to that little area I want. Let that make physical sense. Please. Oh shit, you gotta look it up first, Jim. What's the area? 1.68. 9535. I like it. So that's this little dude here. 9535. And what's 2.45? 9929. So then when you subtract those, what do you get? 0394. There's only, if you got it between a 13 and 1400 SAT scores, you're part of 4% of the population. Oh boy, I think you start to see how every problem is the same basically, right? I mean, they give you an X score, you make it into a Z score, and then you look it up. If they give you a percentage, you look up the Z score, and then you change it back to an X score. It's exactly reverse. So this one, less than 820. I'm going to be down here, 820. Bam, 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 bam. Make a Z score out of it. 820 minus 1083 over 129.2. What do you guys get for that Z score?
Negative
2.04. And if you look at negative 2.04, the nice thing with this problem is 0207. That's below, and the question was for below, so I'm done. 0207, done. That says 0207. So there's only a 2% chance somebody makes less than an 820 SAT. Right? It's not a good thing. I'm only part of 2% of it. Oh, no, it's not good. So 12. Now this means this would be the second percentile. Do you guys see what I'm saying? Because how many scored below 820? About 2%. This would be roughly the second percentile. So this is asking for the 12th percentile. What z-score has 0.12? Who's done that? I did this kind of on purpose. See how this is exactly on either side of 0.12? Yes? Wow. So then the answer to the z-score I want to use is negative 1175, right in the middle. So this would be negative 1175, and then I use that backwards formula to change it back to an x score. So x is the mean minus 1.175 times the standard deviation of 129.2. Holy shit. Okay. Bless you. Bless you. That's money coming your way, man. Everybody know that? 3 sneezes in a row is money coming your way for some reason.
Never happened to me.
You're going to find a penny somewhere and go, really? I guess technically that's true, Jeff. 931.19, is that what you guys said? Alright. That's plenty, man. I'm burnt out. You probably burnt out too, so. Okay. The next time that quiz, first thing. When did you send me the last one? It's been a while? Well, last Wednesday. Okay. Do it again. Well, I think they'll be able to do that tomorrow in the assessment center. You're going to be taking it in the assessment center. And I got to make it first.